teaching learners in the lab, whether it's the research lab, the procedural lab, or a simulated setting. These bring with them natural opportunities for hands-on teaching. But ever still feel stuck in a mode of passive instruction in these settings? I know I have. Hi, I'm Amy Gardner, Associate Dean for Faculty Development and Director of the Academy of Medical Educators here at the University of Colorado School of Medicine. Spend a few minutes with Dr. Chelsea Lohman from the Department of Cell and Developmental Biology and learn some tips for integrating active learning techniques into your next lab session.
Lab-based learning provides a unique opportunity to provide learners with a chance to directly engage with scientific concepts and techniques through hands-on experiments and real-world applications of knowledge. However, if you've been teaching lab learners in this setting as long as I have, it's easy to adopt a routine of introducing the basics of an experiment or a procedure, modeling proper techniques, and providing practical skills for implementation. Unfortunately, this cookbook approach can create a passive learning environment that limits learner engagement, motivation, and deep learning. What a missed opportunity! Hi, I'm Chelsea Lohman, Associate Professor of Cell and Developmental Biology here at the University of Colorado School of Medicine. Today, I'm excited to share with you 5 evidence-based strategies for leading lab sessions that can deepen learner understanding and likelihood of applying scientific knowledge to new settings. But first, what is active learning and why should we care? Active learning is an approach that stimulates intentional engagement, purposeful observations, and critical reflection among learners. The key to fostering high-quality active learning in lab settings lies in creating opportunities for learners to test hypotheses, solve problems, analyze data, and reflect on their findings, all of which deepen their understanding and enhance their ability to apply scientific knowledge. Here are 5 time-tested active learning strategies I've adopted that I'd encourage you to consider adopting as well. The first technique is integrating case-based scenarios. Presenting real or hypothetical research problems will encourage learners to use critical thinking skills and identify and narrow an issue, develop and evaluate alternatives, and offer a solution. The second technique is utilizing reverse demonstrations. For example, you could have a learner teach back a procedure or technique after observing it to reinforce their understanding. You can then follow up using open-ended questions to assess the learner's understanding and ability to transfer that understanding to similar but slightly different situations. Another technique is to incorporate a journal club with debate. Assigning controversial or contradictory studies and tasking learners with defending or critiquing methodologies and conclusions can help learners deepen their understanding of a topic by considering different viewpoints and evaluating viability. Experimental flowcharting is another technique to increase learner engagement and deepen understanding. Have learners map out processes and workflows to give them the opportunity to visualize dependencies and anticipate potential challenges. And finally, incorporating activities like failure analysis and troubleshooting can be both fun and stimulating. Present examples of flawed procedures or unexpected results so learners can diagnose and propose improvements. This can not only reduce the likelihood they make those mistakes in the future, but can also increase their overall understanding of processes and workflow. In my experience, incorporating these 5 strategies, case-based scenarios, reverse demonstrations, journal clubs with debate, experimental flowcharting, and failure analysis and troubleshooting can transform traditional lab learning to a fun, engaging, and creative learning environment. Try one of these strategies today and see for yourself.